Welcome to First Do No Harm with Massachusetts Citizens for Life board member and physician Dr. Mark Rollo. This broadcast will focus on medical ethics from a Catholic perspective and address abortion, physician-assisted suicide, contraception, natural family planning, IVF, healthcare proxy, and other topics.
Hello and welcome back to First Do No Harm, a show about medical ethics from a Catholic perspective. I'm Dr. Mark Rollo. As I mentioned in my last show, since the beginning of the First Do No Harm program, I have spoken about medical ethics dealing with intrinsically evil acts which can be ascertained to be evil by application of natural law theory. Simply put, natural law theory tells us, among other things, that the deliberate destruction of innocent life is never justified. This applies to the beginning of life when we are discussing abortion, and it applies to the end of life when we are discussing assisted suicide and euthanasia. Natural law is reflected in the Hippocratic Oath, which explicitly states, "I will not give a deadly drug to a patient even if asked, nor will I suggest such a thing. Similarly, I will not give to a woman an abortive remedy." These have been the topics that I have addressed thus far. Natural law simply means that human beings have an innate moral sense as to what is right and wrong. It is written in our hearts. St. Paul makes reference to natural law in Romans chapter 2, verses 14 and 15, which states, "For when Gentiles who do not have the law instinctively perform the requirements of the law, these, though not having the law, are a law to themselves, in that they show the work of the law written in their hearts, their conscience testifying, and their thoughts alternately accusing or else defending them." Virtually every culture has prohibitions against murder, theft, and lying. This is natural law. There are, however, many instances when right and wrong are not obvious and require some analysis. Such an analysis involves ethical terms such as double effect principle and cooperation with evil, which can be subdivided into formal and material cooperation with evil. It can be further subdivided into immediate versus mediate cooperation with evil, proximate versus remote cooperation with evil, and so you can see this kind of analysis can get complicated. And as I mentioned last time, this is the case when we are talking about the ethics of vaccine development. Such a topic is very timely since COVID vaccines have now begun to arrive, and I will go into some detail about the principle of double effect and cooperation with evil in the context of vaccine development and use. This discussion will also apply to the way we analyze the ethical nature of any issue. Let us first begin, as always, with prayer. For, as stated by the U.S. Catholic bishops, only with prayer that storms the heavens for justice and mercy, prayer that cleanses our hearts and souls, will the culture of death that surrounds us today be replaced with a culture of life. Father and Maker of all, you adorn all creation with splendor and beauty, and fashion human lives in your image and likeness. Awaken in every heart reverence for the work of your hands, and renew among your people the readiness to nurture and sustain your precious gift of life. Grant this through our Lord Jesus Christ, your Son, who lives and reigns with you in the unity of the Holy Spirit, God forever and ever. Amen. Now, before discussing the ethics of vaccines, and specifically the new COVID-19 vaccines, let me briefly discuss the disease itself. The sources that I have used in preparing this come largely from the National Catholic Bioethics Center, NCBC, and specifically from a member of the National Catholic Bioethics Center, whose name is Reverend Tadeusz Kopolczyk. Father Tad, as he prefers to be called for obvious reasons, earned his doctorate in neuroscience from Yale and did postdoctoral work at Harvard. He is a priest in the Diocese of Fall River, Massachusetts, and serves as the Director of Education at the National Catholic Bioethics Center in Philadelphia. Now, Father Tad is an excellent resource for anyone who is interested in bioethics from a Catholic perspective. He is a brilliant scientist and educator, and strictly adheres to Catholic doctrine. His writings can be accessed at fathertad.com, as well as ncbcenter.org, which has information on a broad swath of bioethics. So, about this disease. First of all, COVID-19 stands for coronavirus disease identified in 2019. The CO in COVID is corona, the VI is virus, and the D is disease. And this was discovered in China in 2019. Scientists refer to it as SARS-CoV-2, which means severe acute respiratory syndrome, SARS, caused by the second coronavirus noted to cause SARS, hence the CoV-2. Now, the first severe acute respiratory syndrome was referred to as SARS, and this was another viral respiratory illness caused by a different coronavirus called SARS-associated coronavirus, or SARS-CoV. This was first reported in Asia in February of 2003. The illness spread to more than 24 countries in North America, South America, Europe, and Asia before the SARS global outbreak of 2003 was contained. These are just two of the many coronaviruses, most of which cause the common cold. And the common cold is caused by other viruses as well, such as rhinoviruses and adenoviruses, and there are others. Now, although COVID-19 can be a very serious disease, and prudent precautions should prevail, such as social distancing, hand washing, face coverings, and so on, it is important to remember that the vast majority recover. For example, among those under age 19, 99.997% recover. So only 3 in 100,000 will actually die from COVID-19 of those who are under the age of 19. Now, I say only, any death is tragic, but we have to put things in perspective. For example, the death rate per 100,000 from motor vehicle accident is about 11. And in this case of death rate of those under 19, we're talking about 3 per 100,000 people actually die from COVID-19. Between the ages of 20 and 49, 99.98% recover. So only 2 per 10,000 people will die. Between 50 and 69 ages, it is still above 99% recovery, 99.5 to be exact. It is only when you get above age 70 that the recovery rate drops below 99%, but still is 94.6% recovery rate for those over 70. So COVID-19 is most dangerous to people over 70, primarily those who are sick with other illnesses, such as other lung illnesses, people with diabetes, people with heart disease, and so on. COVID-19 arose in China. It is believed that bats were the original reservoir for the virus. For some reasons which scientists don't understand, bats can harbor many viruses without getting sick themselves. It appears there was a transitional animal called the pangolin, Pangolin. The pangolin is a anteater. And this animal may have been sold in a so-called wet market in China, and from there the virus transitioned to humans. Many believe that experimentation was being done on bat viruses in a virology lab in Wuhan, China, and it somehow escaped from the lab. But whatever the source, a pandemic ensued, and an unprecedented push for a vaccine began, which was obtained in record time. Now, there are several types of vaccines. One vaccine is the whole pathogen. In other words, the whole organism, virus in this case, is used for the vaccine. The virus is grown, and it is inactivated, in other words, made unable to infect an individual. This is the case in the hepatitis A vaccine, which was recently developed, and it is called Havrix. So this is an inactivated hepatitis virus. Other vaccines using the whole pathogen are the MMR shot, the measles, mumps, rubella shot. This is a live, attenuated vaccine. In other words, the organism is not killed and injected. It is attenuated or made less pathogenic. A third type of vaccine are subunit vaccines. In other words, parts of the pathogen are injected into individuals. This is the case in a tetanus shot. The toxin, which is elaborated by the bacteria that causes tetanus, a so-called toxoid, is identified and purified, and this can be injected into an individual to cause immunity. Nucleic acid vaccines are the new vaccines, and COVID-19 vaccines is included in this category. Now, nucleic acid refers to the instructions in the cell, and this specific instruction that is used is the so-called messenger RNA. This new technology using nucleic acids, in this case messenger RNA, has provided great speed of the development, because instead of growing large quantities of virus in the lab, which are then inactivated or attenuated or broken into pieces so as to find the best piece to inject into the individual, which then generates an immune response, we can instead create genetic instructions to inject into people so that they, the individual, can make the vaccine themselves. These genetic instructions are called mRNA, which stands for messenger ribonucleic acid. Now, I would like to play for you a short clip that was originally presented by Father Tad. This clip does not feature Father Tad himself, but someone to whom he referred to speak about vaccine development for COVID-19. This report was given shortly before the vaccines actually became available. You can access the clip yourself by going to YouTube and entering Father Tad and vaccines into the search bar. Here is the clip.
The push to develop a coronavirus vaccine is moving at high speed. There are several different approaches for a potential vaccine against the coronavirus. The basic idea is that you would get a shot that contains faint versions of the virus. The vaccine would expose your body to a version of the virus that is too weak to cause infection, but just strong enough to stimulate an immune response. Within a few weeks, cells in your immune system would make markers called antibodies, which would be specific for only the coronavirus, or specifically its spike protein. Antibodies then attach to the virus and prevent it from attaching to your cells. Your immune system then responds to signals from the antibodies by consuming and destroying the clumps of viruses. If you then catch the real virus at a later stage, your body would recognize it and destroy it. In other words, your immune system is now primed. Collecting evidence on whether this will be possible, safe, and effective is part of what's taking researchers so long to develop a vaccine. It's a race against time to develop a vaccine amid a pandemic. Each step in vaccine development usually takes months, if not years. An Ebola vaccine broke records by being ready in 5 years. The hope here is to develop one for the new coronavirus in a record-breaking 12 to 18 months.
Now, this was a report from late last year, and as we now know, it didn't take 12 to 18 months to develop the COVID vaccine, but it only took 11 months under so-called Operation Warp Speed. Now, this record-breaking development of a vaccine was partly due to spending huge amounts of money to speed up the process, but mostly due to the new mRNA technology. And now I would like to play for you another piece about specifically messenger RNA vaccines. And this piece originally aired on Public Broadcasting System, PBS.
Vaccines prepare the immune system, getting it ready to fight disease-causing organisms called pathogens. A vaccine is introduced to the body to mimic infection, triggering the body to produce antibodies against the pathogen, but without causing the illness. Conventional vaccines usually contain a weakened or inactivated pathogen, or a piece of a protein produced by the pathogen called an antigen. RNA vaccines are a new generation of vaccines. Instead of the antigen itself, RNA vaccines contain a messenger RNA, mRNA, that encodes for the antigen. Once inside the body's cells, the mRNA is translated into protein, the antigen, by the same process the cells use to make their own proteins. The antigen is then displayed on the cell surface where it is recognized by the immune system. From here, the sequence of events is similar to that of a conventional vaccine. Some RNA vaccines also contain additional mRNA coding for an enzyme, which, after being translated in host cells, can generate multiple copies of the antigen encoding mRNA. This essentially amplifies the production of antigen from a small amount of vaccine, making the vaccine more effective. These are called self-amplifying RNA vaccines. RNA vaccines are easier and safer to produce than conventional vaccines. This is because mRNA molecules can be synthesized in a cell-free system using a DNA template with a sequence of the pathogen. While conventional vaccines usually require a more complicated and risk-prone process of growing large amounts of infectious pathogens in chicken eggs or other mammalian cells. Without the risks of being contaminated by infectious elements or allergens from egg cultures, RNA vaccines are also safer for patients. Because protein synthesis occurs in the cytoplasm, RNA molecules do not need to enter the nucleus, so the possibility of them integrating into the host cell genome is low. RNA strands are usually degraded by cellular enzymes once the protein is made. The relative simplicity of the production process makes it easier to standardize and scale, enabling rapid responses to emerging pandemics. Other advantages include lower production costs and the ease of tweaking RNA sequences to adapt to rapidly mutating pathogens. On the minus side, it can be challenging to deliver mRNA effectively to the cells, since RNA sequences and secondary structures may be recognized and destroyed by the innate immune system as soon as they are administered intravenously. These limitations can be overcome by optimizing codons, using modified nucleosides to avoid recognition, and packaging RNA into protective nanoparticles. Another disadvantage is that most RNA vaccines require uninterrupted refrigeration for transportation and storage, which can be a hurdle for vaccine distribution. Research is ongoing to engineer thermostable vaccines.
Now, one phrase that was included in this clip was the phrase that viruses can be grown in chick egg and other mammalian cells. Okay, so what are these other mammalian cells? Well, they can be from animals, such as hamsters, or, unfortunately, they can be used from the cells or the cell lines from aborted fetuses. And herein lies the ethical problems. So, in the wake of the announcements from multiple pharmaceutical companies about safe and effective COVID-19 vaccines, many are expressing ethical doubts about whether it is okay to take these vaccines. Now, since on its face, it's not obvious that there are any natural law arguments against this, and by that I mean there is no innate moral sense as to the ethics of vaccine development or administration, we need to look a little closer and use other tools of investigation to make an ethical decision. These tools are the principle of double effect and cooperation with evil. So let's begin with the notion of the principle of double effect. This principle is used when an action has two effects, a double effect, one good and one evil. This principle of double effect is attributed to St. Thomas Aquinas in his Summa Theologica, which he initially used to show that killing in self-defense is justified. And there are four principles. Number one, the action itself is morally neutral or morally good. Number two, the bad effect is not directly willed, but only tolerated, and it is not the means by which the good effect is achieved. In other words, the end never justifies the means. Number three, the motive must be the achievement of the good effect only. And number four, the good effect is at least equivalent in importance to the bad effect. An example that is often used is the case of having to or be in a position to remove a diseased uterus from a woman who may have endometrial cancer, and she may be pregnant at the time. So let's analyze this according to the principle of double effect. Number one, the motive is to save the life of the mother, so saving the life of the mother is a good thing. Number two, the bad effect of the baby dying is not directly willed. Number three, the motive is to save the life of the mother. And number four, saving the life of the mother is at least as important as saving the baby. So in this case, ethicists would say that it is ethically okay to perform this hysterectomy because the motive is to save the life of the mother. The bad effect, which is not willed, is the fact that the baby will die in the process. Now, does the principle of double effect apply to vaccine development from the cells of an aborted fetus? Well, we can say that this really does not apply to this circumstance because, number one, the action of abortion is morally evil. It is the unjust killing of the innocent. Number two, the bad effect is obviously the death of the baby, which is originally directly willed. Number three, a partial motive is or can be tissue donation. And in fact, women are sometimes told to try to get them to feel better about an abortion that the tissue from the baby could be used. And number four, the bad effect, namely the original abortion, is much worse than the good effect of creating a vaccine. So clearly, the principle of double effect does not apply here because the original act was evil. So the next question is it evil for us to cooperate with the evil of abortion by using a vaccine derived from fetal tissue? We will go into this next week, and we will do so in detail. Until next time, remember, we should always treat life with care and respect. And at the very least, we should first do no harm.
Thank you for tuning in to First Do No Harm. Dr. Rollo welcomes your questions and comments. You may contact him at markrollo978@gmail.com. That's MARKROLLO978@gmail.com. Thank you, and until next week, remember, first do no harm.